you'll look and see that on the back of this sheet, and for those at home on Edmodo, this is on Edmodo as well if you lose this sheet. It has the breakdown for binomial theorem, which are the first 16 problems. And then you have the properties of polynomials, which is 7 through 16. I know it repeats, but it's because it's from 2 different worksheets. So again, mentioning that all the problems on the worksheets for this week, I'm going to pull the Unit 2A test from those problems. So you have everything here, but for homework, you'll just do the odds. Okay. So let's look at this. For the first 16 problems, the front page there, we're looking at these kind of situations. When it's a plus b to the nth power. This could be the 7th power, the 8th power, the 9th power. It takes forever to do if you do it by hand, so that's why we use Pascal's triangle to figure out the coefficients. And then we work out the exponents, plug in and simplify. Okay, so this is more where I'll remind you by doing this, and a lot of it is kind of the pattern of it. The pattern of it's really important with this. So let's look at, I'll even do one of the problems that you have for homework, just so you can double check. Hey, double check yourself. Let's do number 3. So number 3, you may need to write this on another piece of paper because unless you write really small, some people who write really small can do it. Otherwise, do it on another piece of paper or write it on the side over here, and then you know you're going to transfer it eventually. Here we have x plus 3 to the 5th power. Now, the key information here is going to be what is my n, what is my a value, and what is my b value. Okay, once you know those 3 things, then the process is the same exact thing over and over and over. Okay. So, somebody help me out. What is my n value for this? 5. That's easy. Okay, how about a? What's a? What's b? 3. If this was minus 3, it would be minus 3, but in this case, nope, it's positive. Okay. It's one of those situations, whatever those numbers are there, whatever they are, we're going to go ahead and put them in our a, b, and our n. Okay. So here's the deal. We found a, b. Identify Pascal's row based on the exponent. So our highest degree here is the 5th power. So look on the back, the notes I gave you. Remember that the coefficients, the number that is in front of your variable, in front of AB, are going to be based on, because it is the 5th power, it's going to be based on the 5th row. Okay. So it's going to be based on this 5th row. And the 5th row is, let's see, 1, 5, 10, 10, 5, 1. Okay. We're going to use Pascal's triangle. Remember on the unit test that you can have half a page of notes, one side. So you may want to jot the Pascal's triangle. Or you can always make it yourself, right? Remember how we can always make it 1, then you add it. 1s are always on the outsides. Okay? You can make your own Pascal if you needed it. So decide what you want. If you just want it written out, then that's something you'll do for your note sheet. So here's the deal. We have our coefficients already worked out. Move it over here. Coefficients already worked out, so I'm going to go ahead and bring this down. This is equal to 1. That's my first coefficient right here. 1. It's going to be 1 times an a and a b. Plus, what's the next coefficient? 5 times an a and a b. Plus 10 a and b plus 10 a and b plus 5 plus 1. And those at home can't see that far. So move it. All this stuff. Alright, so you guys remember we were doing this before? You guys have seen this. You remember this part, right? Kinda? Okay. So we have all the coefficients based on the 5th row from Pascal. 1, 5, 10, 10, 5, 1. We leave room for a and b all the way across. And then we look to see, we want to apply the exponents into those terms now. It works this way. If it was the highest degree is 4, our a terms would be to the 4th power, 3rd power, 2nd power, 1st power, 0. But it's not to the 4th. What power do we have here? What's our n value? 5. 5. So I'm going to go with, for every a, this is a, this is b. This is a, this is b, so on. I'm going to go ahead and start with 5. What's next? 4. 3, 2, 1, 0. Okay. It really doesn't matter what problem you were dealing with. If it's to the 5th power, it's based on 5th row of Pascal. It's always going to look like this to start. We just have to fill in our exponents for our b values now. And it starts at 0 and it works its way up to your highest degree. So here I'm going to go with 0. 1, 2, 3, 4, 5. I'm just going to get rid of these A and B's because they're kind of getting in the way. So far, so good. Is that? What's it? Yeah. You say? So, such a long problem, it doesn't even fit. Yasmin, can you pull your the curtain to your left? Yeah, that almost does it. That's pretty close. Yeah, can you pull the other one? Let's just close the other one too. Yeah, Natalie, you're. There we go. Thanks. All right, what should I put in for my A value? A? X. 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 How about for my B value? 3. 3. 3. 3. 3. 3. Okay. Now, this is the part, it's kind of a lot of work just to get it to this point, but really you follow the method every time it works. Now, this is going to be our first term. Our first term we're going to write here, and the key to this is remember that the 5, the 5th power is applied to the x only. The 0 power is applied to the 3 only, and so on. Okay? So, if I look at this, what is any number or value to the 0 power? 1. So this is 1 times x to the 5th power. It's x to the 5th. See? So from here we just whittle it down slowly. Okay, 3 to the 1st power is 3 times 5. 15. So we have 15 x to the 4th. All right, then we have, what's 3 to the 2nd power? 9 times 10? 90. X to the 3rd power. That 3 is applied just to that x. These exponents, those exponents are always applied straight to those, just the term that it's connected with here. Okay. 3 to the 3rd power. What do we have for 3 to the 3rd power? 27 times 10? 270 x squared. All right. 3 to the 4th power. This is where you may have to start using your calculator. But we had 27 times 3, 81. 81 times 5.
405.
Very good. 405. X to the 1st is just x. What is anything to the 0 again? 1. That's 1. 3 to the 5th is answer. You guys remember it now a little bit? You probably might. I hope you remember this part. How the exponents go up and down in opposite ways. Okay. So the steps are up there. You can add that to your study sheet that you can use. How do we feel about this? Thumbs up, sideways, down for binomial theorem? Pretty good, right? Okay. So I'm going to go ahead and move on to the next topic, but I'll let you work in classwork. If you have problems, then I'll do another on the board. We'll work it out that way. Okay, let's look at what's up next. First off, on the back of the page, the bottom 2 properties, sum of 2 cubes, difference of 2 cubes. Go ahead and cross those out, please. On the back of the sheet where it has the polynomial identities, the sum of 2 cubes, the difference of 2 cubes, go ahead and cancel those out, cross those out. That is not actually in the scope of our Unit 2 2A test. The bottom 2 identities there, the cubes, the things with cubes there, you're going to cross out. Okay, let's look at number 7 on the very bottom of the page, front of the page, number 7. On the very bottom, I know there's 2 7s, but it's in this part 2. Yeah,
We're only doing odds from this, right?
that's correct.
This is the cost one.
That's correct. So let's look at number 7 right here. We have into the 4th minus 100. The first step for this is a different topic. The first step is to look and see which one of these identities right here does our problem look like. Which does it look like? And I always look to see, well, if the expression is inside parentheses, it's possibly these two up here, but they're not like that. It's more like this form right here, a squared plus b squared, which is minus b squared, which is the difference of 2 squares right here. But the thing is, we need to get this, we need to force this expression into that form. We need to force that expression to be a squared minus the b squared.
So m to the 4th minus 10 is 40?
Very close. I like the 10 part.
Something.
In something, and that's correct. It's going to be different than into the 4th.
Right.
And the way that I figured this out is, I know that if into the 4th represents the a squared term, and I want to know what a is, then all I need to say is, well, what is the square root? Or in other words, what times what gives you into the 4th? What times what gives you 100? And what would you say for the 100? That might be a little easier. 10 times 10. What times what gives you into the 4th? What squared gets you into the 4th? N squared. N squared, right? If we have n squared times n squared, really, if we break it down accordion style, we have n times n times n times n. Everyone agree with that? N squared is just 4 n's. 4 n's multiplied together, n times n times n times n into the 4th. We haven't changed anything. What we've done is force it. We forced it in here to be n squared minus 10 squared. So first you have to force it into the form. However, you can do that. There's a lot of practice on here for that, so don't worry. So now what I've figured out is my a value is n squared, my b value is 10. Honestly, once you're done here and you know what a and b are, you're done. Well, don't finish, don't stop, but you're done with what you have to really work on. Because look, I look at my identity, and I know that it's equal to a plus b, a minus b. So because we've found a and b, and this identity works every single time, I can go back here and just say, well, I know my a value is n squared plus my b value is 10, and then n squared minus 10. That's my final answer. Right there. Who doesn't like this part? Who doesn't like having to force it when it's a higher degree? Yeah, it's not that great, so we'll do another one like that. I think you'll start to see the process and why we have to do it. We have to force it that way. Maybe a little bit more later. All right, let's go ahead and do the next problem. Top part done? Good. If it's not, you got to look on with someone else. Because I need more space. All right, somebody else pick a problem for me to do. Part 2. So from the very bottom of the page to the back of the page. What should we do? 13? All right, looking at 13. Good choice to go with the odd number. Minus 36 squared. All right. So again, which one of these does this look like? Which one of these does it look like? Look at your identities, or your properties there. Difference of 2 squares again. We know we're going to try to force it to be in this configuration, a squared minus b squared, the difference of 2 squares. So if I look at this, I'm going to go here and just say, well, I want to put this in a squared form. So what times what gives me 400? 20 and 20. So essentially what I've done is I've said 400 is equal to 20 squared, which is in the configuration that I need. It's some value squared. So we force it in that way, right? So again, let's go. I have 400. I need it to be an a squared minus b squared form. So I need to express 400 as some value squared. So I found that it's 20 times 20, so 20 squared. Now it's been forced into that configuration, to that form. Okay, force it that way. How about this one over here? Let's deal with it one at a time. What times what gives me v squared? V times v. How about 36? Square root of 36? 6. So it's minus 6v squared. I have not changed anything with this. All I've done is forced it into my a squared minus b squared by really essentially taking the square root of each. We've just taken the square root. And you can think about that. This is really just to get our 20, we've taken the square root. To get our 6b squared, we've taken the square root of that term. Now, like I said, this is pretty much, you're good to go, you're ready. This is a, this is b. So I'm going to rewrite this as, who can help me with the last part? Yeah, Haley.
20 minus 6b.
20 minus 6b?
Then 20 minus 6b again.
Almost. Because remember, it was, maybe I misheard you, so sorry. So plus, and then 1 was minus.
Oh, that one would be the plus. It's going to be plus 6.
Oh, is that what you said there?
Or just flip flop, yeah.
That's what you had?
Yeah.
Our communication went like this, but if that's what you got, we're good. All right, perfect. All right, who feels a little bit better with this process? A little bit? Who needed that? Good? Yeah. Thumb sideways still? Like this. All right. There's only one other thing I need to show you. And for that, I'm going to erase this. All right. Let's do... No, I'd actually... I want to do number... we should do 15. But not because it's one you have to do for homework. It's actually the one I wanted to show. Yeah, right. I'm going to change these ends to be x's. Right. First thing you want to look at with this is, can I factor something out of each of those terms? Is there a number that is a part of each of those terms that I can divide out? 10. How do you know it's 10? What's the clue? They end with 0. So when it ends with 0, you know you can divide out 10. So I'm going to go ahead and put this here, and I want you to write what is left over when I divide out a 10. I brought a 10 out. What's left over with my 3 terms? Go ahead and rewrite that out there for you. Or go ahead and rewrite that out. So this is 15 on the back page. Yeah, cough drop. I feel like I almost do. I haven't been talking as much. That's not true. All right, first term. You divide out of 10. What do you end up with for the first term? Second term? Third term? Okay. Now, this is a little trickier because if you look at these identities we have to deal with on the back page, right? You can either look at, you can look at, you can look here to see which one it matches, but you can also look at what they equal over there. So which one does this look like? Which one on the back, there on the back page? What's the name of the identity that, just what's inside the parentheses, just this trinomial here. What does that look like closest on the back? Square of sum. And it's the answer, right? It's the expanded form of that. All right. So the situation is when I have the square of 2 sums, I end up with a squared plus 2ab plus b squared. My goal right now is to find what is my a value, what is my b value. The only place we're going to look is our first term and our last term. A and b are part of our middle term, but if I find what a is, which is going to be easier if I look at the first term. And b, looking at the second term, I don't even need to look at that middle term. Because if I look here, x squared is equivalent to a squared. So what is my a value? A squared is x squared. My a value is equal to what? X. I'm going to show you how I got that. What I'm saying is that our a squared is in the position of x squared. So really what you can do is think of it this way. A squared is equal to x squared. How do I solve for a when I have this situation? A squared I don't want. So instead of squaring it, what's the opposite? Square root. We square root both sides. It gets rid of the square on both sides. We get a is equal to x. Right? So that's how I figured out my a value from the position that it's in. And now let's just do it for the second one here. Essentially what we're saying is what is in the position of b squared is 25. So what is my b value? Just 5. You could have set it up. You could have said, well, b squared is equal to 25, and I square root both sides. b is 5. Okay. So from here on out, the 10 stays every time because the 10 was factored out. It doesn't disappear. But now I'm looking here, and I started here, and I wanted to factor it into this form. So I know what my a and my b are. I'm just going to put them in there. A is x. B is 5. That's my answer. You see, so we're using the identity. Sometimes we have to go either direction with the identity. Just where you start. From where you start, you're going to be able to see which direction to go. Thumbs up, sideways, down for this guy. All right, you got a few to work on with this one. Who wants to see one more? Okay. Speak up. I don't know if I'm going to do another that you have to do for a classroom. What's the fun in that? What's the fun? Man, day back from break. Everyone is not happy. Let's do 12. Number 12. 3 plus 6b. I'm going to change this to x. 6x plus 3x squared. So if you wanted to, you can go in there and put it in descending order. But say we wanted to leave it just like this. First thing, is there anything I could factor out from each of those terms? What can I divide out from each term?
3.
So this 3 is going to be left there. It's going to be all the way back down in the answer. 3 divided by 3, 1. 6x divided by 3, 2x. 3x squared divided by 3, x squared. So if I distribute back, it better end up where you started. In that case, it definitely would. Okay. And this looks like it's like the same as last problem. So I know that I'm working on that a plus b squared is equal to a squared plus 2ab plus b squared. So here's the deal. We have it in this form over here. We have it in this form. We're going to get it into the sum of the square of sums. Okay. So let's look. A squared corresponds to 1. If a squared is 1, what's a? I know this is the hardest part. It's 1. The reason being is a squared. This is like a form you have to fit things into. Okay. A squared is equal to 1. A. So since a squared is equal to 1, if you need to do the baby step with this, there's nothing wrong with that. A squared is equal to 1, so when I square root both sides, a is 1. Okay. If you need to do that step, that's fine. So we have a is 1. B squared corresponds to what over there? Crickets. Don't have my sound effects handy. X squared, right? So again, if you need to do the baby step, you can look and see that, well, b squared is equal to x squared. So if I square root both sides, b is equal to x. Okay. So what is figured out is b is equal to x. Somebody help me out. What's going to go here? TK, what do you think? Remember, it's based on this.
Oh, your A and your B.
Yeah.
A is 1.
Mm-hmm.
And your B is X.
What goes between them?
It's plus.
Done. All right. Who doesn't like this part? The crux, I think, is if a squared is equal to 1, what's a? Who doesn't like that part? Okay. You don't need it.
Mr. Lin here? Is there Mr. Lin?
Mr. Lin?
Yes. Yes, I borrowed.
Oh. Resume this. Okay, here's the deal. If you're still struggling a little bit, you're going to work as partners on all the odds. Call me over. I'll do one of the evens with you on this because there's only just a couple people. And I want to let you, give you 17 minutes. You can probably get through all the odds, at least the homework done. All right, guys. You're almost done. 17 more minutes. I know it's a long day. I feel it too. We can do it. We can do it. All right. I need help. You guys are better at this. What is my giveaway? What's my giveaway for my 200th subscriber?
Black Friday
$5 Starbucks.
Black Friday surprise.
But I'm not going to get to 200 today. Anything else?
What are you after?
Oh, a taco, 12 taco pack.
I kind of like the idea
Taco
of passing
Bell,
12
12
tacos.
taco pack. With the drink and whatever else included.
But what if your subscriber is smart? You're going to send them tacos.
Or they're vegetarian. It's true. Because the veggie tacos at Taco Bell wouldn't be good. $5 buy something.
Starbucks, no way.
What?
No
Okay,
way.
make it $6. Because I know they were packing like 5 or 6.
Yeah.
So you can make it $6. You try to tap.
It's all the brain energy in here. All right, how about this? Ah, your favorite cereal. All right, we're going to go with the giveaway is going to be a reasonable amount on a Starbucks gift card. Oh, what card?
Not everybody likes
Dashboard.
Dutch Bros.
Dutch Brothers. Okay. We're going to go the 200th, get something from Starbucks, or a bag of chips or some kind of chocolate. Chocolate and chips?
your choice.
Chocolate chips. All right, subscribe on 3. What's that? 1, 2, 3?
Subscribe.
Please subscribe.
Please.